Howdy, howdy, howdy. So today we're going to be looking at the ways that you can use Excel to do some calculations with counting, so combinations and permutations in this case. So in this case we'll be looking at two questions we'll be answering. But first let's look at some of the functions we see in Excel. So this first example we'll look at is what if we wanted to count the number of permutations on 7 objects taken 3 at a time. So to do this, you would type your equals symbol to tell Excel that you're about to enter a function, and then write permute. Notice it's not permutation, it's just permute. And then inside parentheses, you'll put first the number of total distinct objects you're talking about. In this case, that's 7. And then you'll put the number you're taking, which in this case is 3. And then you'll close out your parentheses. And so in this case, you hit enter and you get 210. So that's the number of permutations on 7 objects taken 3 at a time. Now, let's suppose that instead you were looking at the number of permutations on 7 objects where you're taking all 7 of them. Well, there's 2 ways to do this. One of them is you can basically use the same function we just used. So in this case, permute. Sorry, I had a little bit of a hiccup here. So we type in permute, and then 7 comma 7 in this case, we're taking all 7, and I got 5,040. Okay, but if you know how permutations work, you can also just say, well, I know that that's just going to be 7 factorial. So what if we just wanted to calculate 7 factorial without talking about this permutation function business? Well, that's easy. You just type in fact for factorial, and then you'll have 7 in your parentheses for your input, and hit enter. And in this case, we get 5,040 again, which is what we expect. Okay, so now, what if we wanted to talk about combinations instead of permutations? So remember that with combinations, the order doesn't matter. And so the numbers are usually going to be smaller, so we expect, actually not usually, they're always going to be smaller. So in this case, we would know that it should be less than 210. So here I'm typing in combin, short for combination. And then in parentheses, again, we're going to put 7 comma 3 because it's 7 objects taken 3 at a time. And sure enough, the result is 35. And so that is less than 210, and that makes sense. In particular, it's 210 divided by 3 factorial. Okay, now that we have that, oh, by the way, you wouldn't bother doing combinations of 7 objects taken 7 at a time because that would be just, 1. Okay, so our first question here is how many ways can the letters in the word copyright be arranged? Now here I'm going by all the letters and counting that there are 9 letters in here. And notice that these letters are distinct. There's only one C, there's only one O, and so on. So there's 9 letters, and we're taking all 9 of them, right? We're not looking at words we can make from there or something. We're looking at just arrangements of all 9 of those letters. So that means I'm going to use either the permutations of 9 comma 9, or I can just use factorial, and that's what I'm going to use here, is I'm going to look at the factorial. Okay, so go ahead and calculate that, and the result is something doesn't quite fit in here, so I had to make the column a little bit wider, and now we can see our answer. And so at this point now, it's good to write our answer using words. Okay. By the way, right here, what I'm doing is I'm noting that if you wanted to show more digits or something like that, you could go in and open the formatting menu. Okay, so let's let's go ahead and write our answer in words. And so then the letters in the word copyright can be arranged in 362,880 ways. Okay, so that's it for our permutation example. Let's look at our combination example. Now we have a set of, in this case, 7 objects. It's the set of 2, 4, 6, 8, 10, 12, and 14. And then we're looking at how many of those subsets have exactly 4 elements. Now over here, on the right side of the screen, I'm noting that if you change the order of sets, that doesn't change the meaning. So here we have that if I wrote them in descending order, it would be the same as if I wrote them in ascending order, or if I just mixed them up entirely. So that means we're not looking at we're not looking at permutations, we're looking at combinations. So we're looking at sets of these elements that have exactly 4 elements in them. So we want to make clear we don't include things like 2, 2, 2, 2. That would be a set of 1 element, because if you repeat an element in a set, it's the same as if you just wrote it once. Okay, so these have to be 4 distinct elements. And so we're talking about the number of combinations on 7 objects taken 4 at a time. So I'm going to go ahead and type in my combin function and write 7, 4 as my inputs and hit enter. And notice that I got 35, which is the same thing I got for this combinations of 7 objects taken 3 at a time. We'll talk about that in a moment. But before we do, let's go ahead and write our answer in a complete sentence. So there are 35 subsets of this set we have here, 2, 4, 6, 8, 10, 12, 14, that have exactly 4 elements. So let me finish writing that out. Okay, so now let's talk about why it is that we ended up getting the exact same number we got before. Why did we get 35 again? Is it a coincidence? No. It's actually because 4 plus 3 equals 7. So let's talk about why this should be true. If I were to take the 4 elements that I have that form a subset, then and take them and put them separate, okay, then there would be 3 leftover elements, and so those form their own subset. Okay, so for example, if I were to look at 2, 4, 6, and 8 as my 4 elements, my subset, then 10, 12, and 14 will be the elements that are left over. Okay, and so since every 4 element subset corresponds to a distinct 3 element subset, because putting those together will form the 2, 4, 6, 8, 10, 12, 14 set, then it makes sense that there's going to be the same number of 4 element subsets as there are 3 element subsets. So let's look at some examples here. So for example, if I were to say, hey, how about the subset that contains 2, 4, 6, and 8? Well, that would correspond to the leftover subset of 10, 12, and 14. Okay, what if I looked at a different subset? How about a subset of, that one should be a 2, I'll fix it in a moment, 2, 8, 10, 14, okay? Then the 3 element subset it corresponds to are the leftover elements. So the first leftover element is 4, and then the next leftover element is going to be a 6, and then the last leftover element is going to be 12. And so that's our 3 element subset. So every 4 element subset corresponds to a distinct 3 element subset, and vice versa. So that means that they're the same number of those. They are in what we call a one-to-one correspondence with each other. Okay, so that's why you expect them to be the same in terms of the context. We could also expect that they're the same based on the formula for the number of combinations. Okay, so if you recall, the number of combinations You can write it as C of n comma r. You can also write it as n and then capital C and then r, or you could use the binomial coefficient notation. There's a lot of different ways. So this is equal to the quotient of n factorial and the product of n minus r factorial times r factorial. And so in our case, we have n is 7, and in one of these cases, r is 3 and n minus r is 4. In the other case, r is 4 and n minus r is 3. And that's because 4 plus 3 equals 7. So what this means is when you calculate both of these, the number in the bottom is just, it's the same product. It's just whether what order you multiply them in. So that's it. I hope you found this helpful, and have a lovely day.